FET224 computer system. So in this video we're going to be looking at different computer architectures. So the question here is, which of the following is a computer architecture where each instruction is divided into multiple stages? E.g. we have a fetch stage, a decode stage and an execute stage, amongst other possible stages in the processor, and multiple functional units execute two or more instructions in parallel by slightly shifting the instructions in stages. We have A, pipeline, B, multi-core, C, superscalar, and D, VLIW. So let's have a look here at pipeline processing. Pipeline processing is a type of techniques that provides simultaneous or parallel processing within the computer. Pipeline processing divides the execution cycle of each instruction into multiple stages in the processor, and multiple functional units execute two or more instructions by slightly shifting the instructions in stages. So it's quite hard to understand what is actually being depicted in words here. So let's have a look at a graphical diagram. So before we actually look at a detailed picture of what pipelining looks like, it's worth understanding some of the instructions we need to use within the processor. So various cycles are involved in instruction processing. These fetch, decode and execute cycles for several instructions are performed simultaneously. This process is referred to as instruction pipelining. To apply the concept of instruction pipelining, we must subdivide instruction processing into a number of stages given below. So the stages we have are stage 1, stage 2, stage 3, and stage 4. In stage 1, we use the fetch stage. This will read an instruction from main memory. In stage 2, we have the decode stage. From this instruction, we then decode the opcode and fetch the source operands if necessary. In stage 3, we have the execution stage. We perform the operation specified by the instruction. In stage 4, we have the store stage. Here we just store the result in the required destination. So here we have a graphical representation of a 4-stage instruction pipeline. Here instruction processing is divided into 4 stages, hence its name. So what we can see here is we can define time slots. Time slot 1, time slot 2, time slot 3, time slot 4, time slot 5, time slot 6, time slot 7, and so on. And these are just pretty much clock cycles. So every time a clock cycle goes high, we move on to the next stage or cycle as I've defined them here. What we can then look at is what instructions happen in time slot 1. Well, in time slot 1, first of all, we run our fetch 1 command. So our fetch 1 occurs here, and it occurs in these 4 time slots. So first of all, we fetch 1, then we decode 1, then we use the E stage 1, and then the S1. Secondly, we do this on instruction 2. Now, instruction 2 can immediately start on the second clock cycle. And the reason for that is because the fetch of the first instruction has moved out by the second clock cycle into the decode stage. We can then start our second fetch. So fetch 1 starts on the second clock cycle and so on. This means that by the 4th clock cycle, we have 4 concurrent instructions, I1 to 4, running in the same time. So here you can see that we can run 4 instructions simultaneously. And if this was to continue, as soon as the instruction 1 had finished, we could then start with instruction 5, I5, and this would be here, F5, and then D5, and so on. And this could happen on all 4 lines. So we could run I5, then we could run I6 out the back of I2, and I7 out the back of I3. This enables us to have a constant stream of instructions running to improve the processing of a CPU. So in this instruction pipelining, 4 instructions are in progress at any given time. This means that 4 distinct units are needed, as shown in the figure. These units are implemented such that they are capable of performing their own task of executing two or more instructions using multiple units simultaneously and in parallel without interfering with one another. Therefore, A is the correct answer to the question that we had been posed. Let's have a look at some of the other options that we had within our answers. Firstly, multi-core. A multi-core processor enhances processing performance by allocating processes to multiple processor cores. This is an explanation concerning a processor in which pipeline processing is not adopted. However, when multiple processor cores operate simultaneously, contention for shared resources may occur. C, superscalar, is the technique of simultaneously executing multiple instructions by further dividing the pipeline mechanism into multiple stages, with increased processing performance during the execution of multiple instructions. Finally, we have VLIW, or very long instruction word. This omits the time-consuming operation of determining the possibility of parallel processing by the CPU through the compilation of extremely large group of instructions that must be processed in the sequence into a single instruction. And so here we can see the answer is going to be A, or pipelining. So in this video we've learned a lot more about how we can use pipelining to improve CPUs, but also some other methods that can be used.